Look up at the night sky, see that bright shining star? That's not a star at all. That's Venus, our closest planetary neighbor. Venus is often called Earth's twin because of its similar size and mass. Imagine a planet roughly the same size as our own, a world with mountains, valleys, and perhaps even volcanoes. Early astronomers, peering through their telescopes, dreamt of lush Venusian jungles teeming with strange and wonderful life. But as we've come to learn, Venus guards its secrets closely. Venus, despite its beauty from afar, harbors a secret. This planet, often called Earth's twin due to its similar size and composition, is anything but a hospitable sibling. It's the hottest planet in our solar system. Its surface temperatures can reach a scorching 900 degrees Fahrenheit, hot enough to melt lead. Why so hot? The answer lies in its thick, toxic atmosphere. Venus's atmosphere is composed of over 96% carbon dioxide, with clouds of sulfuric acid, creating a runaway greenhouse effect that traps heat. This makes Venus even hotter than Mercury, the closest planet to the Sun. Venus is trapped in a runaway greenhouse effect. Its thick atmosphere, composed mainly of carbon dioxide, traps heat from the Sun. This creates a stifling, unforgiving environment. The sunlight that penetrates Venus's dense clouds is absorbed by the surface and then re-radiated as heat. However, the thick atmosphere prevents this heat from escaping back into space, causing surface temperatures to soar. This process is similar to what happens in a greenhouse where heat is trapped inside, but on Venus, it's on a planetary scale. The pressure on Venus's surface is intense, 90 times that of Earth's. Imagine being a mile beneath the ocean's surface. That's the kind of crushing pressure you'd experience on Venus. This immense pressure is due to the thick atmosphere, which weighs down on the surface with a force equivalent to being 3,000 feet underwater. Such conditions would crush any human-made spacecraft not specifically designed to withstand them. Volcanoes dot the landscape, spewing lava and adding to the already hellish atmosphere. Venus is home to more volcanoes than any other planet in our solar system, with over 1,600 major volcanoes or volcanic features. These volcanoes are not just relics of the past, some may still be active today, contributing to the planet's extreme conditions. The volcanic activity releases gases into the atmosphere, further intensifying the greenhouse effect and maintaining the planet's scorching temperatures. The surface of Venus is a dynamic and ever-changing landscape, shaped by the relentless forces of volcanism and atmospheric pressure. Could anything survive on the surface of Venus? It seems highly unlikely. The extreme heat would instantly fry most life as we know it. The crushing pressure would make even the toughest deep-sea creatures crumble. And the acidic rain, a product of the toxic atmosphere, would be the final nail in the coffin. While the surface of Venus seems inhospitable, what about its atmosphere? High above the scorching surface, temperatures are cooler and the pressure less intense. Could life exist in the Venusian clouds? It's a tantalizing possibility. On Earth, we find microbes thriving in the most unexpected places: volcanic vents, acidic hot springs, even the frozen wastelands of Antarctica. Could similar life forms have found a way to adapt to the challenging conditions of Venus's atmosphere? Life in Venus's atmosphere would still face immense challenges. The clouds themselves are composed primarily of sulfuric acid, a highly corrosive substance deadly to most life on Earth. Water, considered essential for life as we know it, is scarce in the Venusian atmosphere. And while temperatures are cooler higher up, they are still far from hospitable, reaching hundreds of degrees Fahrenheit. To truly understand Venus and its potential for harboring life, we need to go back. Our fascination with Venus dates back to the early days of space exploration. The first missions to Venus provided us with invaluable data, but they also left us with more questions than answers. These early missions laid the groundwork for what we know today, but the technology of the time limited our ability to fully explore and understand this enigmatic planet. Now, with advancements in technology and a renewed interest in planetary science, we are poised to uncover the secrets that Venus holds. Several missions are planned in the coming years to study Venus in greater detail. Space agencies around the world, including NASA, ESA, and Roscosmos, are gearing up for a new era of Venus exploration. These missions aim to answer some of the most pressing questions about Venus, such as its geological history, atmospheric composition, and potential for past or present life. Each mission will bring its own unique set of instruments and objectives, contributing to a comprehensive understanding of the planet. These missions will analyze the planet's atmosphere, map its surface, and delve into its geological features. By deploying advanced probes and satellites, scientists hope to gather high-resolution data that will reveal the planet's secrets. The atmospheric analysis will focus on understanding the chemical composition and dynamics of Venus's thick, cloud-covered atmosphere. Meanwhile, surface mapping will provide detailed topographic maps, helping us understand the planet's geological history and the processes that have shaped its landscape, and search for signs of past or present volcanic activity. Venus is known for its volcanic features, and understanding its volcanic history is crucial for piecing together the planet's geological past. Probes will be equipped with instruments to detect and analyze volcanic gases, thermal emissions, and other indicators of volcanic activity. This data will help scientists determine whether Venus is still geologically active and how its volcanic processes compare to those on Earth. One exciting development is the discovery of phosphine gas in Venus's atmosphere. This unexpected finding has sparked a flurry of scientific interest and debate. Phosphine is a gas that, on Earth, is typically associated with biological processes, raising the tantalizing possibility that it could be a sign of life. However, there are also non-biological processes that could produce phosphine, so further investigation is needed to determine its true origin. On Earth, phosphine is often associated with biological processes. It is produced by certain types of bacteria in anaerobic environments, such as swamps and the intestines of animals. The presence of phosphine on Venus raises intriguing questions about the potential for similar biological processes to occur in its harsh, acidic atmosphere. Scientists are now exploring various hypotheses and conducting experiments to understand how phosphine could be produced on Venus. While it's too early to say for sure, this discovery has certainly piqued the interest of scientists searching for life beyond Earth. The detection of phosphine has reignited the debate about the possibility of life on Venus, and has led to renewed efforts to study the planet in greater detail. As new missions are launched and more data is collected, we may be on the brink of a major breakthrough in our understanding of Venus and its potential to harbor life. The coming years promise to be an exciting time for planetary science and the exploration of our neighboring planet. Scientists believe that Venus may have once been a very different place. Billions of years ago, it may have had oceans of liquid water and a more temperate climate, much like early Earth. If so, could life have arisen on Venus during this more hospitable period? Could some remnants of that ancient life still cling to existence in the planet's atmosphere? These are questions that future missions to Venus hope to answer. Venus, our enigmatic twin, poses more questions than answers. This planet, often called Earth's sister due to its similar size and proximity, is shrouded in mystery. Despite being one of the brightest objects in our sky, its surface remains largely hidden beneath thick clouds of sulfuric acid. These clouds reflect sunlight, making Venus appear so bright, yet they also conceal a world that is incredibly hostile. Its scorching surface and toxic atmosphere seem to defy the possibility of life. With surface temperatures reaching up to 900 degrees Fahrenheit, Venus is hotter than Mercury, even though it is further from the Sun. The pressure on Venus's surface is about 92 times that of Earth, equivalent to being 3,000 feet underwater. This extreme environment is dominated by volcanic plains and mountains, with evidence suggesting that volcanic activity may still be ongoing. Yet, the tantalizing hint of phosphine and the possibility of a more hospitable past keep us wondering. Phosphine, a gas that on Earth is associated with life, was detected in the clouds of Venus, sparking debates and excitement in the scientific community. Could this be a sign of microbial life, or is there an unknown chemical process at play? Additionally, studies suggest that Venus might have had liquid water and a more temperate climate billions of years ago before a runaway greenhouse effect transformed it into the hellish world we see today. As we continue to explore our celestial neighborhood, Venus stands out as a constant reminder of the vastness of the universe and the mysteries it holds. Missions like NASA's Parker Solar Probe and ESA's Envision aim to peel back the layers of Venus's atmosphere and surface, providing us with more data to understand this enigmatic planet. Each discovery brings us closer to answering fundamental questions about the formation and evolution of planets, including our own. Perhaps in the swirling clouds of this seemingly inhospitable world, we will one day find evidence that life can take hold in the most unexpected places. The search for life beyond Earth drives much of our exploration, and Venus, with its extreme conditions, challenges our understanding of where life can exist. Whether we find life or not, studying Venus helps us appreciate the delicate balance that makes Earth habitable and underscores the importance of protecting our own planet.